1-to-1, then you go for partial injection function. Okay? If you use all the records from the domain, from the range, all the records from the range, then you go for partial surjection function. Okay? If bijection means both range are actually 1-to-1 and on-to, you go for bijection. Normally for bijection, you can go either partial bijection or total bijection. But the symbol that you will see, you have both. Okay, but the one that I put in the lecture slide is for total bijection symbol. Okay, so if partial means you have one line in between them. Okay, so that is partial. So in order for us to do in our Z schema, remember mostly the biggest symbol, okay, after relation. A relation is the biggest, but the second biggest will be partial function. So when you have domain which are not duplicated, the domain data which are not duplicated at all, something like primary key and so on, then automatically minimum will be partial function. Okay? Don't go for total function if you does not know the data will have no mapping at all or not. Okay? If you have a relation, totally is many-to-many relationship already. Okay, so that's how you do for your assignment. So when you do function or relation, no need to use power set anymore. Remove the power set because the relationship already shows many records. So you don't have to put power set anymore. Okay, so you don't have to put power set anymore. Just go to show the relationship between this and this. No need to put power set anymore. So that is something that you have to remember about the chapter 3. Chapter 3 lah. So remember also, last week also we discussed about how to do the operation, for example, how to do the operation schema, for example, to display the records and so on. So all the operators that you have learned previously, let's say domain restriction and anti-restriction and so on, you need to know which symbols that are actually used or going to be used to solve the problem. Okay, not every symbol will be used for everything. So you have to know this symbol actually suitable to use for which operation symbol or operation schema. So that's why your operation for your assignment, you need to know which symbols to be used. When you choose the wrong symbol, you will get wrong result already. You forget to put one keyword, you actually produce wrong result also. Okay, so make sure that whatever that you do, okay, whatever the symbols, whatever the operations that you want to do inside your operation schema, make sure that you know what is the output that you want to produce, what will be shown on the screen or whatever, and then, or you want to update your database, how to do that and so on. So which symbol is the most suitable. Okay, sometimes you may have more than one suitable style of answering the question. Similar like programming. Different students will have different way of writing. So same thing like Z schema, you may have different way of writing also. Okay, so it's up to you how you want to solve it. But that's why your operation schema, first thing that you want to do, when you want to do operation schema, what is the purpose of your operation there? What is the result that you want to get from that operation? Okay, so from that result is, let's say you want to produce output. What kind of output that you want to produce? Is it for one single record, or your output is actually as a report, the whole sales report, for example? So you have to know what kind of result that you want to produce to show the way to show the result later. For example, if you want to produce a single record, then you don't need to put power set at all because it's a single record, no need power set. But if let's say you want to represent the output as a sale record for the whole month, for example, from this date to this date and so on, then your output will be different already. your output will be more than 1. So when it is more than 1, you need to show using power set already. So all this is actually something that you have to know, or you have to think, especially when you want to do the operation schema. Okay, yeah. And another thing also, when you do precondition, okay, when you do the precondition for your operation schema, make sure that all the preconditions are going to produce true result. Okay, your precondition must always be true. If your precondition produce false result, then you cannot proceed with that operation schema. And something wrong with that. So means your operation schema is not success anymore. So it is not or shouldn't be there anymore. Okay, so that's why whatever that you choose are the 3 operations for your assignment. So make sure that your preconditions are actually related to what you want. Always true. Okay, so that's why, for example, you want to check exist. If you want to update the record, the record must exist in your database. So that is precondition. You cannot update if the record does not exist. So all this you have to ask yourself, what will be the precondition before you can produce? Because your operation is something that when you do operation schema must always be true and must be success. Okay, your operation schema must be success schema, not fail schema. Because when you have a fail scenario, then you are going to proceed with another what we call as error scenario. So chapter 4 later will be related to that part. Okay, so up to now, up to this week, your operation schema, whatever that you do for your operation schema for the assignment, the result must always be true. Okay, it means that whatever that you do, success schema, not fail schema. You don't have to consider if fail or not. No, you just consider this condition confirm your operation will be a successful schema. That's all. Okay, this is what we call as operation schema. So after operation schema, the next step is for you to do the what we call as error scenario. So error scenario is the schema to actually do the exception handling or error handling. Means that if the record does not exist, what happened? How you want to handle that error? So that is what we call, what you are going to learn in chapter 4 under error scenario. Okay, so now let's proceed with our next chapter. So chapter 4 here. So before we go for error scenarios, we will discuss about the operators first. Okay, so for chapter 4 here, okay, this one relate to Z schema operators. And the word there, schema operator. Okay, schema operator means you have one schema. How are you going to combine these 2 schema if needed or not? So can you combine this and this together or not? Okay, so the one that you learned previously, all the symbols, all the operators are for the statements inside your schema. Okay, like domain, restriction, whatever, all those inside your operation schema, the statements inside that. So one operation, you may have many operations there. So those are for the statements inside the schema itself. But now, assuming that you have 2 schema here, you can combine these 2 schema together, for example, to show another output or to show other things. Okay, as a result of this schema and this schema, you can get this schema. So in order for you to do that, you have to choose the correct symbol. So we are going to present as schema operators. Okay, so the most useful schema operators that you are going to see later will be conjunction and disjunction. These are the one that you are going to use later. Conjunction and disjunction. You may have heard about conjunction and disjunction before. Okay, and then you may have also heard about negation. Later you will see also other schema operators that if you refer to the Google Classroom, I give you one example called schema inclusion already. So those are actually other operators that you also can use in your schema. Okay, and then after that you are going to learn about error scenarios and complete schema, how to produce a whole complete schema. Your assignment, okay, until complete schema, your assignment part. So it means that whatever that you do in your report, the last part of Z will be the whole complete schema. Okay, the next chapter, another extended Z structure is something that you may or may not want to add into your assignment. It's okay if you don't want to have it, but it's also okay if you want to add it, because that one is not compulsory for you to add in your assignment. Another chapter, not this chapter. Okay, but for your assignment, the last part of your assignment will be until complete schema here. Means that whatever that you do in your assignment, you have to show until complete schema. Okay, and then the rest of the parts, all those are actually either your group parts or individual parts other than Z schema will be in your report lah. But what I'm talking here is about Z schema. Okay, so starting from the first time that you have done basic type and so on, so the last part of your assignment related to the Z schema will be complete schema, or we call as total function. Okay, so the first schema operators that you will use a lot, we call as conjunction, okay, also known as AND. Okay, in your programming, whatever, you have AND operator, right? So that is conjunction. Okay, so what we mean by conjunction here, so if you want to do conjunction, normally you must have at least one variable which is the same between these two schema. Normally we'll have two schema, one variable must normally will have to be the same. Okay, at least one variable must be the same because you want to do conjunction. Okay, so what you are doing in the conjunction, the declaration part will be combined into one. Okay, combine lah means that you list all the variable from both sides, both schema, into one long list of variable. Okay, but when it comes to the predicate part, okay, the constraint part, the condition part, all the statement from both sides separated by AND operator, conjunction. Combine all, but each of the statement will be separated with conjunction symbol. AND means all the statement must have AND operator there. Okay, so when you do conjunction here, okay, for example, I have A, B here variable, B and C for these two schema. Schema, we are talking about schema now. We are not talking about variable or what. We are talking about schema S and schema T here. Okay, you have variable declaration and then you have the predicate part for S and T also. So whatever the statements that you have there, then whatever the statements that you have in T. So what you are going to do, make sure that at least one variable must be the same. So in this case, we have B of type B and B of type B here. Okay, so same variable, same type and so on, then you can do conjunction. If needed. If needed, if not needed, no need. If needed, means that you want to produce a new schema with the combination of these two. If needed, then you go for conjunction. Okay, so what happened is, you list, the result will be the conjunction of S and T, another schema, you can put it another name for it. Okay, and then the declaration will have all combining to here, A, B, C here, and then the below part will be conjunction here. Means that all the statement here must have conjunction operator. Okay, so that is the rule. That is the rule for conjunction. Okay, for example, let's say I have two schema. One is the quotient, one is the remainder. Okay, so for quotient, I have this variable of type N. For remainder, I have this variable of type N also. Then for quotient here, I have the statements here. Okay, the condition here. D not equals to 0 and N equals to Q times D plus R, for example. Okay, these are my statements. Okay, inside of my expression, inside the quotient. And then for the remainder, R less than D, for example. You can have other things, and this is only example on how to do the conjunction. Okay, so I want to produce what we call as division. Okay, division, how to say, a division schema where I need to combine these two together. Okay, I want to combine quotient and remainder together to produce a new schema called division. So how to do that? This is the new division name, same here. Okay, and then you have NDQR, so you look back at quotient, NDQR here RD, so R and D also same. So you don't need to duplicate R double R or D double D, no need. So you list down your variable here, and then all these you list down. Remember, when inside the statements or the constraint, at the end of the line here, okay, there is a conjunction operator. It's okay not to put the operator. Okay, if you want to put operator also can. You just put conjunction here, another conjunction here. Okay, but for conjunction, it's okay not to put the conjunction symbol. Okay, so that is if, let's say, you want to combine schema with another schema. If you don't want to combine, it's not compulsory for you to do. It's not compulsory. Okay, but if, let's say, you have operation here, these two are actually need to be used together to proceed with another thing and so on, then you may need to use conjunction. Okay, so you will see later how your operation schema works and so on. So this is example of conjunction. Okay, disjunction is another one that you may see later also. Okay, so disjunction, this is the symbol for disjunction. Or we call for all. Okay, how to do disjunction? Okay, it's similar like conjunction. The declaration part will be the same. Like if let's say you have two schema, the declaration part will be listed all together. Must have at least one variable same for both. Okay, so that is conjunction. Disjunction. Okay, but the predicate part, okay, the predicate part will be all condition, means either this or this. Okay, either this or this or this, whatever lah. So we'll have disjunction operator. Okay, just now is conjunction, means this and this and this. That is conjunction. But when it comes to disjunction, this or this or this, how many statements that you have in your predicate part. Okay, so same thing like S and T just now. If let's say you have disjunction, so you must have at least one variable which is the same. And then for the declaration part, no problem, will be the same as your conjunction, no problem. But when it comes to the predicate part, it will be disjunction already. Okay, disjunction already means all. Okay, that is the symbol. Okay. Assuming that just now, we have division just now, right? We have division just now. Okay. The one that combine quotient and remainder. So we give a name as division just now. So now we have a schema called division. Okay, we have a schema called division already. So let's say you have another schema, in this case called divide by 0. Okay, let's say you have another schema called divide by 0. It's a separate schema. So you have division just now, then you have divide by 0. Okay, but these two is either one. Either you do division or divide by 0, for example. So it's either one. Cannot comes together. You cannot do division or divide by 0 at the same time. Okay, then you will have a problem with your calculation, for example. Okay, so it's either this or this. Okay, either you do this schema or this schema. Okay, so in order for you to show that it's either this schema or this schema, you can do disjunction, schema disjunction. Okay, so how to do that? For example, I put the name T division. Okay, let's say I give the name as T division, division or divide by 0. Disjunction, disjunction, divide by 0. So this one DQR, just now you have NDQR, so it will be at least one variable must be the same. So we have 3 now already the same. You list down all here. Okay, but when it comes to the predicate part, the first part here, this is from division just now. Okay, means that I put into one single line lah. If you want to do 3 different lines, you have to put conjunction also. Okay, so now I combine into one single line, and then you separate, you combine here with conjunction inside here. Okay, you combine with conjunction. But when it comes to, because either one, all this is from 1, all this from division by 0 is 2 separate. 2 separate. So you put bracket like programming lah. You put bracket, then you put disjunction operator. So either the first part here or the second part. Either one. This one is similar like if you want to do something like if-else statement. Something that you want to do if-else statement for your operator. Okay, either this or this. So if you want to do something like if-else statement, another way to write is by using disjunction operator. Okay, but for your if-else statement, you don't need to do separate lah. Straight away you go for this one. You understand? You don't need to do 2 separate operator, one for the first part, another for the second part, then you do combination of this. No need. If for your operation, if you have if-else statement, for example, you just no need to do part A, part B, then you combine as part C. No need to do that. You just combine everything without having part A and part B at all. Just straight away create your schema with disjunction inside that. Okay? So that is one of the way for you to show something like if-else statement also. If this, then you proceed here. If else, you proceed here, and so on. Okay? So you use disjunction operator. Okay. So negation, okay, normally we didn't use for our operation because normally for our operation we want to be success. Okay, we don't want to have success. So normally for not success, we will go for error scenario later. So just to let you know that you have what we call as schema negation in your Z schema that you may or may not use later. But this symbol, negation symbol, this is the negation symbol you are going to use later in extended Z structure. Extended. So you are going to use this symbol later. But maybe not in your schema, but later in chapter 5, you will need to use this operator, especially to do the error scenario. Okay, so for now, just remember that this symbol means negation. Not. When you put in the programming exclamation mark, right? For not, right? So this one you don't have exclamation mark. Don't use exclamation mark. Exclamation mark is for the output. So it's 2 different things. So for the schema negation, the symbol is this one. Okay, the symbol is this one. So means not means not. So you have this, not this means this. Okay, so if you want to have that condition, then you can put negation symbol, not operator. Okay, schema inclusion. Okay, so this is the one that if you have seen inside your Google Classroom, I gave you example of schema inclusion. Okay, schema inclusion means you add inside the declaration part of another schema. Okay, inside the declaration part. So you have 2 ways of writing. If let's say, you are, it's actually all the state space, all the schema belongs to you. Okay, this is your own state space. Let's say you have one big, you are doing, for example, what? Order and delivery, for example. You alone do order and delivery module. Okay, you can just simply do one schema, order and delivery module. Then whole thing about order inside there, the whole thing about delivery inside that, inside one schema. You can do that. It's not an error because that is belongs to you, your own module. Okay, but in terms of whether it's actually good to proceed later or not, my suggestion normally I will tell you to split into two. Okay, into what we call as two-state space schema. Okay, why we want to split? Because when you do the operation later, if let's say you are talking about delivery, okay, you update all the delivery information lah. Maybe the date lah, the ID for delivery, blah blah blah, address related to delivery. But if you combine into one, okay, if you combine into one state space, order and delivery module, one whole state space, what happened to order variables there? Okay, because nothing, no changes for order variable. Then later, when you do operation to add delivery, for example, you must put remain unchanged for all the variable for order just now in your operation. Then let's say now you have 20 variable, 5 used for delivery, another 15 for order. So 5 update, the rest of 15 will be remain unchanged. You have to do that. Okay, but the operation is called add delivery, for example. So you still have to do it because your state space combine all into one. Okay, so that is why, okay, I will suggest you to split. So you do one order, one delivery. Okay, so when you want to add delivery, you just call delivery state space. Okay, no need to call order state space. Okay, so from there, whatever changes that you do there, you don't have to put remain unchanged for the order. Okay, and then maybe later you have operation that you want to produce report combining of order and delivery information, that means combine. Then you call these two state space together because you need both sides of the information. Okay, so this is where you do schema inclusion and so on. Okay, so when you do schema inclusion, normally you are actually merging, combine the declaration part. Okay, and then all the constraint, all the condition will be conjunction. It's like you split or without split, it's the same thing. Okay, but without splitting, you will have to put remain unchanged variable, a little bit long list. But when it comes to the split, then it's shorter a little bit. Okay, shorter your operation schema a little bit. Okay, for example, okay, let's say I have box office here, seat to customer, power set of seat, for example. And then I have customer here, status, and sold seat customer here. So you can see that here I have here sold seat to customer. Here also I have another variable same also. Okay, so if you want to have a combination here, you can have one way. Either you can have box office, this one, box office here, put or combine into friends here. Means that, okay, you have the same thing, the one that same just now, sit here, no need to be duplicated anymore. Okay, so you can have this as another way to solve your problem. So this part is what we call as schema inclusion, this part. Okay, this is schema inclusion. State space into another state space. So that is schema inclusion. You include another schema into another schema. Okay, so this is what we call as schema inclusion. Include one schema into another schema. So this one is you include state space schema into another state space schema. Okay, so schema inclusion. Okay, so this is actually the schema inclusion. Or, if let's say you want to combine as a whole system, for example, you can have combination like this also. Okay, so this is also schema inclusion. Okay, this is also schema inclusion. Okay, so normally for me, I will go for this one. Okay, but up to you. Okay, up to you. But this one, okay, later maybe I will show you the files from the Google Classroom to explain to you what is actually mean by that. Okay, so that is actually another way of writing the schema inclusion. Okay, later I will open, so I will explain later about schema inclusion from the file. Okay, another operators that you may need to know also, we call as schema hiding. Okay, schema hiding, similar symbol like difference, like remove. Okay, remove. So what happened in schema hiding? You don't want to show variables inside your schema. Okay, so schema hiding is popular if, let's say, you have variable, optional variable. For example, like a form, there are actually compulsory variable, and then there are optional variable from your form. For example, when you want to get the information, maybe name, ID, email is important, but address is optional for them to fill up. Age also optional for them to fill up. So if optional means not compulsory for them to fill up, rather than you ask them to fill up, make it as a must, you can do what we call as hiding. Hide the variable inside your variable declaration, but you put inside the predicate part. Okay, so you can use what we call as schema hiding. But of course, when you want to do schema hiding, you have to use there exists variable. Okay, there exists means if there exists this data, update your record, for example. If there exists this one, update this one. Okay, so there exists existential operator. Okay, so I will just show you this one. This one is mathematics, so you have to use there exists lah. There exists, but I will go for this one. Easier for you to understand. Okay, assuming last time, cannot remember, is it chapter 2 or chapter 3? I think chapter 2. Last time I show you one operation schema called add member last time. Okay, I think from chapter 2 or chapter 3. You see, you refer again lah. Okay, so we have actually, I've shown you this one. Okay, I've shown you example only, example. Normally, if you want to add member, you need the member information. That is a normal case. But I don't want to show other example because that one is not in the slide. But I just take this example to explain to you how to show for your hiding part. If let's say you want to have something that requires the information, but the most important part, the main part, the one compulsory, you declare on top lah, something like this. Okay, you declare on top. Okay, whatever the compulsory information, you declare on top. Okay, because those are compulsory information. Let's say you want to have name, ID, email address, phone number. Those are information which are actually compulsory. You declare on top. Okay, you declare on top. Don't look at this. This one because I want to show how you want to do schema hiding. But if let's say for your operation, you don't have to do step by step like this. You just do once enough. Okay, because if you know which one that it's a must or compulsory, another one is actually want to hide means optional, and straight away you just go for that. Okay, for the optional part, how to do it? Okay, for example, assuming this is let's say on top here you have other variable lah. The one optional, the one is compulsory, you declare on top here. Okay, this one I just have one variable only here. Assuming that this variable is optional, means that up to the user whether they want to fill up or not. Let's say address, for example. Address is not compulsory for you to proceed. They don't want to add, is okay. They want to add also, no problem. Okay, assuming that is the case, optional. So if you want to have that variable, because it is optional, not compulsory, you do there exists inside the predicate part. There exists, you declare your variable, similar way, then you put the dot, this one, and the for the operation symbol here. Then if there is exists this input, okay, for this part, okay, then you want to update your database, for example. Okay, so you do like this. Okay, so something like you want to have like something like if else statement also. Okay, is either you use there exists. When you go for there exists, you don't need to use disjunction. You can have many like that. Okay, you don't need, because there exists here means something like if else statement already. Okay, that is one way. Or another way is you declare all your variable on top here. That is using the conjunction just now. Disjunction just now. Using or operator. Disjunction operator. So it's up to you how you want to solve this. Okay, you can use or operator, but you have to put all the variable on top. Okay, means that if you are talking about memory use or whatever, because you declare your variable compulsory, then you are using the storage already, memory storage already. Okay, so in terms of that, you will use a lot of memory space lah. Okay, when you use disjunction. For this one, it's like something like you are trying to save space, memory space, because you are not declaring the variable at that moment until there is data related to that. Okay, if no data, then you are not going to do anything for it. Okay, so it's either you use there exists operator or you use disjunction operator. The result will be the same, because those results will actually show you similar like if else statement lah. Okay, this one is similar like if statement. You know, you have if or the or if. Okay, so if you have if statement, you normally go for there exists. Okay, but if you have if else statement, normally we will go for disjunction operator. Okay, so look at what you want to produce in your operation later lah. Okay, there are cases where you may want to use there exists operator, this one, or you want to use disjunction. It's up to you. Okay, it's up to you. So follow your way of writing the statements lah. Okay, which one do you prefer? Okay, so that is schema hiding. Another operator that you can also use, you have learned the same symbol already. We call this as composition. Okay, composition means that, okay, you use fat semicolon, not the normal semicolon from the keyboard. This one is actually using the fat semicolon. So what happened in composition is, okay, effect of one followed by the other. Means that from one, then it will affect another one. Okay, it will affect another one. So means from one schema, affect another schema. Okay, so means that you have after state of the first operation, okay, and then before state of the second operation. Okay, so but of course for this one I don't give you, because I need to show you a very long step. This one I didn't give you example, but when you want to do schema composition, it's not simply do how to do changes. No, you have to know the rules. Okay, to do schema composition. Okay, if let's say you have the first operation schema, the first operation schema, whatever, or you have the prime variable, right? Okay, the prime variable, you are going to replace the prime variable with double prime. From the second schema, operation schema, all the unprime, all the normal operator, normal variable, you have to put double prime. Okay, so all the double prime from first and second, okay, then later is something like you can remove it lah, because same same. Okay, you can remove it. Then the predicate part you use Z exists operator, because it's like not how to say it's like you don't totally remove. It's like you hide this double prime variable, put inside the predicate part. That's why you need to use there exists operator. Okay, so it's like composition. You are going to actually combine it a bit with hiding also just now. Okay, you are going to combine it a bit with hiding, but this one I don't give example here. Okay, another one which is also popular is what we call as schema piping. Schema piping is similar like composition. Okay, similar like composition. Okay, composition we are talking about the first operation will have effect on the second operation. We are talking about effect affecting the second operation. That's all. But when we talk about schema piping, we are talking about the output from the first operation will be the input of the second operation. Output and input. Okay, it's similar like composition, means affecting, but here also affecting. Just that now we are deeply talking about input and output already. The first operator, output from the first operator will be the input of the second operation. Okay, second operation. Something like some of you said, I need to get the output from order before I can proceed with the payment. Okay, if you want to show the link, then you have to go for schema piping. But in your assignment, normally I will just say, don't go for link schema piping. What we are going to do, what I told you, we go for schema inclusion. That one is easier compared to schema piping. Okay, so there are a few ways you can solve the problem. But the one that normally I give to you, the best, the easiest is to go for schema inclusion. Means that you include your friend's module into your operation, meaning that you are talking now with your friend's operation already. So whatever the output from the result from there, you take and then you continue with your operation. So if you don't want to do that, then you have to go for schema piping. Okay, if you don't want to do the schema inclusion, you have to go for schema piping. Means that the output from your friend's module will be the input for your operation module. So the process is, okay, the output and the input must be the same type. Cannot be different type, because the output for here is the input here, must be the same thing. Cannot be different. Okay, and then you have to rename the output. This one, let's say y output and y question mark is the input. So you have to rename, give a new name for it. This is the step. You have to rename it. For this case, let's say I rename as P. Rename the variable. So I will have something like this. P, here also P. When I have P like this, same variable, right? I can do conjunction. Okay, the next step is to do conjunction. This is a step for piping. So it's a little bit longer steps. Okay, so I do conjunction. So combine. Okay, combine the conjunction here. Okay, after you do conjunction, okay, then you do schema hiding. You hide P because the same thing, input and output. So you don't need it because it's already, you want to show part of continuation. You want to show there is a continuation in your schema there. Okay, so you hide P. Okay, you hide variable P. So you use schema hiding here. There exists operator already. So that is another step. So the first step, you look at output and input. Rename these two. Okay, make it the same variable name. Okay, then combine these two as conjunction. After you combine, then the same variable just now that you change, okay, hide it where using z-axis operator. Okay, that is the steps. If, let's say, you can simplify the version, okay, it means that something that you have done there, you can simplify it, then you simplify it to make it shorter. Okay, but this one is mathematics, okay lah. For us, sometimes we cannot simplify because of our Z-schema operators. So, this one, because mathematics, you may have statements here that you can simplify. You can simplify it. If not, no need to simplify. That's why normally you have that exist as the last one. Okay? So, at the end, your result will be something like that exist also lah. So, that's why for your assignment, I didn't ask you to follow schema typing. But if you want, it's okay to go for schema typing. It's not compulsory for you to do schema typing. You can if you want. Okay? And then there are also implications, but I don't think we are going to use schema implication. Means if this implies, it means if this is true, meaning this is true also. Implies. Okay? If this is true, meaning this is true also. So implies. So I haven't seen any of your senior do implication. So most probably you also will not do schema implication. Then also equivalent means that this schema is equivalent to this schema. For example, let's say you want to do the same operation, but different way of solving the problem. But the problem solved with style A, then this is style B. Okay, same thing. At the end, you will get the same result. Then you can show as schema equivalence. If you want to do that, can. But it will be longer because you show two different results. But at the end, two different style, but the same result will be produced. Okay, but you can show that if you want. So in order for you to show that A and B here is the same thing, you use schema equivalence. Okay, schema equivalence. So the symbol is this one. Okay, not one line, should be double line. Okay, that is for schema equivalence. Okay, and then another thing is that you need to know in terms of the proposition, where the association, left to right, right to left, all those things. Okay, so if let's say you have conjunction and disjunction just now, normally will be from the left to right. Okay, and then for the implication and also implies and also equivalence, normally right to left. Okay, for others, in terms of if let's say you combine and so on. So that's why when you do the schema operators, it's good for you to put bracket. Because if you want to solve this one first, put bracket. Like you do programming, put bracket. Okay, if you don't put bracket, it will follow the associativity stated already for that. Okay, so whatever that you do, if you feel that you want to solve parts, this part first rather than this part, put bracket. Okay, bracket is important for you to solve the problem. Okay, any question under here before we take a few minutes break? Any question? Okay lah, we take around 5 minutes break, then after that we continue.